Hello everyone, welcome to IGBits. We train, you learn. Today we shall review work power energy topic. Without further delay, let's get started. We have our YouTube channel. Visit us at IGBits in YouTube. Please feel free to subscribe and click on bell icon to get the notifications. Your support is very important for us to work together to share many more knowledge sessions across. Okay. Thank you all who are actually being with us and supporting us. This is a great platform that we are aiming for. Thank you all once again. Let's revise work definition. Work is said to be done when a force applied on a body displaces the body through a certain distance, right, in the direction of force. I'm repeating. Let's say this is a block of mass m, and then you applied some kind of a force, right, to move the body towards the right direction. Let's say. So I'm just putting a dots here. You applied some kind of force F at the angle theta. So what happens is by doing that, you are assuming that like no, this body is moving certain distance. Let's say d. Okay. Then so the body is moving in the direction of force. This is a net force, right? If you can componentization, what would happen here? This is nothing but F cos theta. We all know. Correct now? So let's see. This is F condition, right? If this is F, we have a horizontal component, we have vertical component. Vertical component sin theta, horizontal component cos theta. So we are saying like in the direction of right displacement. And hence F cos theta is actually the force and then d is the distance. Right. So the work done is defined as work done equal to dot product of F cos theta into d. So magnitude of horizontal component and magnitude of distance is equal to your work done. So FD cos theta. So sometimes people will say like instead of D we can also use S. That way it is nothing but Fs cos theta. Clear? So work done is a scalar quantity. We all know. You know why? Why quantity is a vector quantity? Because this is a dot product, it's not a cross product. Vector quantity is product of vector quantity is a cross product. Mathematically we derived that this is like a dot product because we are just multiplying the magnitude. Okay, so in the higher classes we can get to know more in detail, but for now let's think of this is a scalar quantity and then this we use like a dot product and then F cos theta and then D would be your work done. Shall I move to the next topic? So what's the units of work? So we say work is equal to F into S. Force means like a Newton and distance is nothing but your meters. So N into M. We can also say like in joules in SI systems. So Newton meter or joules would be the units of work, right? So in our problems we most frequently refer these units as well. Sometimes we might end up actually converting from the one system to another system. You have to be careful to read the problem statement and understand like what is the units are given versus like what is the final ask. Clear? Can you derive the dimensions of the work? So the work equal to F into S, F dot S. We all know that F means what? Force into displacement or distance. The force means like ma because we know that F is equal to ma, right? right? So mass means like m power 1. Acceleration a means what? Velocity by time, right? Velocity means like again L into t power minus 1 by t power minus 1, right? So L power t power minus 2 would be your A. Let's and then displacement yes. So now you say dimension for m is equal to m power 1. Acceleration means L into t power minus 2, and then distance or displacement for which you are say like L power minus 1. So if you can put them together, m power 1 L square t power minus t would be dimension for the work. You have to always remember this one. Clear? Let's assume your net force representing in terms of like in vector notation, x component, y component, and z component, right? In the direction of I plus direction of j plus direction of k. This is given. And then let's look at s component now. X of I plus y of j plus z of k is given. Then what is the work done is work done equal to F dot S. Vector representation of Fx of I plus Fy of j plus Fz of k dot product of how much? Xi plus Yj plus Zk. What we discussed about dot curve I into I equal to j into j, I mean j dot j, k dot k equal to 1. This is the only thing we have to multiply. All I components you can multiply. So fx of x component plus fy of y component plus fz of z component. This is what your work done would be. So you will be getting some of the problems stating that like force in vector notation and then displacement may be a point A to B. Let's say S is moving from A to B, right? Then what would be RAB? So as a displacement is nothing but RB minus RA. So to arrive this equation. So we let's see like one example problem and then you should be able to get the concept. Let's look at this dot product problem. So we have done F equal to F dot C S, right? Force a body of mass M. So M is given like in 1 kg and then moves from point A to point B. So relative position AB, A to B is nothing but RB minus RA is given. And this is vector notation IJK, right? This is the vector notation. So what you have to do, the relative position RB, so 3I plus 2J plus 5K, right, minus how much you have to see RA 2I plus 3J plus 4K. Then subtract this one 3 minus 2 1I and 2 minus 3, that means this is a minus value. What you have to see minus you have to put now minus J and plus 5K minus 4K is plus K. This is what is given. So based out of this F into S, F means 2I minus 4J dot product of I minus J plus K. So how do you write this one? 2 into 2, 2 into 1 1, because in the dot product, right, I into I is nothing but 1, j into j dot j equal to 1, and k dot k equal to 1. That is what it is. And the rest of all products is 0. In a way, 2 into 1 plus minus 4 into minus 1 plus k is a 0 here of 1. So 2 plus 4 plus 0. So 6. 6 joules is your answer. Clear? So small, very small problem, because mass 1k, 1 kg, this is like unnecessary in your case. But R means like F, displacement is given, that is A to B, so B minus A would be your vector. And then you are doing like a simple I component, J components, K components with segregating by applying this sign rule. Now we know the dot product I into I is equal to 1, J into J equal to 1, K into K equal to 1. Right? So, and hence we are only multiplying I component, J component, K component respectively from F and S. And hence what you get is like this much. So joules is your answer. Clear? Let's look at this problem statement. This is very interesting. There are the three forces applied on a particle to move from position A to position B to the position C is what given. So work done by the forces is what is asked. In this case, like when you have like a multiple forces are given, all you have to see is like you have to apply, you have to get the net force. Net force is nothing but a summing of all the forces, like F1 plus F2 plus F3. Remember, right? This is what you get it. Let's say sum this one. What's happening? Your F net would be 2 plus 1 plus 3 is 6i, right? Minus 3 plus 1 plus 1. So minus 3 plus 2 is minus j, right? And 2 minus 2 0, so plus k. This is your net force. When comes to here, you are at A position, moving to B position, from there moving to C position. So what is the relative position you have to find out is RCA is what you have to find out. So all you require is like a C point and A point. You don't consider this point, right? In this case. So how do you calculate now? 2 minus 1, right? 2 minus 1 of I, and how much, what is the next component? J component. So 2 minus of minus plus 1 of j, right, plus k component, 0 minus of 2 of k component, correct? So what this would be now? 2 minus 1 is like 1, is it? So 1i and 3j and minus 2k meters. This is in newtons, right? This would be in newtons because of the force. This would be newton meters because of distance. Now work done would be force dot displacement. From vector theory, what you see, I into I, j into j, k into k is what you are going to consider. So 3j is 6j, sorry, 6i and 1i. So you have to multiply 6 into 1, 6 into 1 plus minus 1 j component, what I am multiplying, into 3 plus 1k multiplied by minus 2, right? So how much you get it? 6 minus 3 minus 2 is what you got. 6 minus 3 minus 2. So how much this value would be? 1 joule. So make a note actually. I think in the vectors we recap for what we studied. I dot I equal to 1. J dot J equal to 1. K dot K equal to 1. Rest of all becomes 0. That's why our multiplication is always goes into I into I component, j into j component, I into I component, j into j component, and k into k component. That's what we are saying. Clear? So work done by the force equal to 1 joule. This will be our answer. Clear? Yeah, this is a very good example. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Logically, we reached end of the session today. We shall continue remaining in tomorrow's class. Thank you all who are joined and participated actively in today's class. See you all tomorrow. Stay tuned to next session. Thank you. Have a good day. Bye bye.